Kindergarten children are expected to work with several different types of addition and subtraction situations. These situations are the kindergarten equivalent of word problems, although the very first situations that you pose will be very likely to be grounded in classroom context, things that are happening, or really clear visual images, not necessarily as a canned word problem. We'll take a look at some of these early problem formats in some subsequent lessons. Addition and subtraction situations have a variety of possible problem structures, and the Common Core authors have been very clear about which problem types need to be familiar to kindergarten children. So in this lesson, we're going to spend time examining these problem types. We are looking right now, we're in the operations and algebraic thinking domain, and we are looking at Standard 2, solving addition and subtraction word problems. As we look at the standard, you will notice that there's no reference to the problem types that I just mentioned. It isn't indicated which problem types should be emphasized. The information regarding the problem types is actually in the Operations and Algebraic Thinking Progressions document for kindergarten through 5th grade, and that is a companion document to the standards also written by the Common Core writing team. Another interesting aspect of this standard is that there's no reference to equations here. Although kindergarten children are expected to be seeing equations modeled very regularly, and almost certainly attempting to write some of their own by the end of the year, they are not required to have yet mastered that skill. The topic of equations is going to be picked up next week when we explore representations. I realize this chart is too small to read, but we'll be taking a closer look at several sections of this chart. But I wanted you to see the whole thing briefly, just to get a reference for what it looks like. It's on page 88 of the Common Core Standards. And it outlines the full variety of problem types or structures of word problems. Children in 1st grade will be exposed to all of these. In kindergarten, the list is shorter, but 1st graders are expected to have worked with all of these, and by the end of 2nd grade, they're expected to have mastered all of them. There's a couple of really hard types here that 1st graders work with, but not all of them will master. This is essentially the same document in black and white, but this one's in the progressions document rather than in the standards document. And it outlines which of the problem types have to be mastered at kindergarten. So those that are shaded darker, those are the kindergarten ones. There's 2 on the top, an add to, a take from, and then 2 different kinds of put together take apart problems. Then the white ones that you see are the ones that are so hard that many children may take till 2nd grade to master them, but 1st graders work with all of these problem types. Action problems is the first group we're going to talk about, and just to go back to the chart, the add to and the take from, the 2 top rows, those are action problems. Put together take apart is non-action. So we're going to talk a little bit about that, because it turns out that whether it's an action problem or a non-action problem is very relevant to working with students developing problem solving. Action problems are characterized by a change in situation, and that change is associated with some kind of an action. The action could be an add to, like I'm joining 2 sets, or separating, or a take from. I have a set and I'm going to take something from it. So in an action sequence, you can really think of it as a kind of chronology. This happened, then this happened, then this happened. You have a starting quantity, then there's some kind of a change. That change is characterized by an action as well. That change either involves something being added to that starting set or something being removed from that starting set. And then as a result of that change, you now have a new end product. And so that's your end result. So this is a chronology. Action problems actually tend to be easier for the most part for children than non-action problems because of that chronology. It turns out it's a lot easier to act out a situation that involves action than one where there isn't action. So kindergarten children are expected to work with action problems, although they're only required to really master these problems that have a result unknown. The change unknown and the start unknown are more difficult. While some kindergarten children may be able to work with those by the end of the year, it is not designated as being a focus area for kindergarten. I indicated that action problems have a kind of time sequence and that chronology is useful to young children as they begin problem solving. Young children do not necessarily read the top problem that you see here with the add to. They don't necessarily read that and say, 2 plus 3 equals question mark. And in fact, that equation is really more to help you see what the structure of the problem is like. I have a set of 2, then I have a set of 3 joining it, and I'm trying to figure out the end result. So the equation is really more for your teacher benefit. But when children read the problem, they do not mentally get an image of 2 plus 3 equals question mark. Rather, they're really thinking about the situation, very contextualized to the story. They use the story to help them figure out the answer. They will likely use tools such as counters or fingers or drawings to act out the situation. And this represents the earliest stage of problem solving. The top problem here should be considered easy by the students by the end of kindergarten for several reasons. First, the action in the problem is very clear. It's easy to figure out the starting situation, the change in the situation, and the result just follows naturally from that in the wording. The easier the problem is to act out, the easier it is for children. Secondly, the number set sums to 5, and the Common Core authors have specified that children exiting kindergarten should be fluent in all number combinations up to 5. This section of the chart illustrates the result unknown problems, but it allows you to see kind of these other 2 problem subtypes as well, change unknown and start unknown. Now, even though kindergarten children do not need to know the other types, I'm showing this chart to highlight to you something important for your teacher knowledge. If you look carefully, you will notice that the add to problem types are not all addition, and the take from problem types are not all subtraction. For example, both of the add to, change unknown, and start unknown are classified as subtraction problems if we were going to just talk about what operation would you use with those numbers that are provided. And the reason they're subtraction is because the numbers include a known total and a known addend, and the other addend is missing. The take from start unknown problem would actually have to be solved with addition, even though it's got a take from action or take away action, because of the fact that you know 2 parts or 2 addends and you don't know the total. Now, these problem structures are not designated for kindergarten mastery because of that very feature. They are difficult for that reason. First grade children will have to start focusing more on mathematical relationships than just on the perceived action of the problem. It isn't subtraction merely because the action is takeaway, for example. Now, while that AHA is designated for first grade, you would do your children a great benefit in kindergarten by getting them to really make sense of problems they're reading and thinking about, and starting to attend to what's a part, what's a whole. We're going to talk about part-whole relations later and elaborate on that feature, but that could be really critical to helping them begin to free themselves from just the action and begin to think about the mathematical relationships that are present in a word problem. Now, we've been focused on action problem types, but now we're shifting to another class of problems that kindergarten children will be working with. In the Common Core, these are called put-together take-apart problems, although you may have heard the alternative term part-whole problems. These problems are non-action. 2 parts are put together to make a total quantity, or a total is partitioned into 2 parts. Now, the work that children do with put-together take-apart problems is really going to support their growing knowledge base of part-whole relationships and also help to build their capacity to compose and decompose number. And again, we'll get more into that in detail when we get into part-whole relationships. So let's talk about how these problems are different from action problems, because I said they're non-action. If you read through these sample word problems, you will see there's no action sequence. It's no beginning, and then this happened, and then now we have this. The first 2 problems are about red apples and green apples. No apples are being eaten or sold. There's just simply this group of apples, and some are red and some are green. And then the last problem involves flowers and how they could be distributed between 2 vases. Again, there are no flowers joining or leaving the group. 2 of the problem types here, the 2 that I just mentioned, are designated in the kindergarten Common Core. And in the first example, you see we have 2 parts that are known, and we're searching for the whole, So that's called total unknown. And the other kind of problem tagged for kindergarten is essentially a decomposing problem. In this case, we know a total value. We don't know either of the two addends. It's our responsibility to generate what are some number combinations that would create that total. I want you to notice the equations because you'll be modeling the equations for these problems. And I want you to notice that the way the equations are written for the both addends unknown shows the total on the left side of the equal sign. The Common Core authors have expressly stated that they want kindergarten children to sometimes see the total written on the left side of the equation. And there are reasons for that. We're going to explore that a little bit next week when we talk about representations. Here we actually have an example of a take-apart, a put-together take-apart total unknown problem, and the prompt was given verbally, but the children are using paper manipulatives to record the combinations they found. This activity actually followed a reading of Baa Baa Black Sheep, and it was one of several math activities that used Baa Baa Black Sheep as a contextual situation for its basis. But here you see you have 7 bags of wool, and you're trying to consider the different ways that you could split those bags of wool up between the master and the little boy who lives down the lane. With entry-level problem solving, it's important to remember that children are not really coming in with a large database of number relationships, so they can't really decontextualize word problems very well into number sentences. Instead, they are really dependent on the context at that stage because they more or less just follow that situation to support their limited knowledge base. So problem solving is actually one of the ways in which children actively build a mathematical knowledge base of numbers and number relationships. So if your curriculum uses situations that are not ones that your students can readily make sense of in terms of the context, then by all means change the situation to one that's more familiar to them, because we have to recognize that for kindergarten children they need that story context initially. They will, as they go through the first grade, they start to distance themselves from the need for that context, so being so dependent on it. But at this stage, that's really important. So if your curriculum uses situations and word problems that aren't ones that your students can make sense of readily in their own context, then like I said, change it to a situation that's more familiar to them. And you can make up problems about students and their hobbies. If you like to find out, like do little surveys and send home to their parents, tell me about your child, a lot of times those can be turned into word problems. You can use real life situations that just crop up during the school day. You can use your read aloud literature as a context, similar to what you saw previously with Baa Baa Black Sheep. Some children's literature was practically designed for this purpose, such as the book How Many Snails by Paul Gigante Jr. Other literature that you read could be extended that way if you're looking for those opportunities. So children can be drawn into mathematical situations and gradually learn how to mathematize those situations, and that's really a prerequisite for subsequent problem solving in first and second grade and even beyond. As you design your own word problems, keep in mind that children will solve them most easily when the relationships are as clear as possible. So this means it's a particularly good idea, that it's not a particularly good idea to get involved in telling some really elaborate story and then just asking a math question at the end. So you wouldn't start a word problem out like, well, the other day I decided to go to the snack shop because I'd been working hard and I was feeling a little hungry, but when I got there I didn't know what to buy, and so I looked at this chips aisle, and then do you see how it's too much information? Initially, make it a lot simpler. Don't let the story obscure the mathematical elements. Both of the examples shown here do use a much more clear action sequence, which should be easier for your children to access. But the bottom problem is going to be much harder for children because weight is a continuous quantity. And we gain weight incrementally. We don't just, go around one size and then 1 whole pound comes all at once. And it doesn't come in pound intervals. So discrete objects are separate entities that can be easily counted as individual items. And so those are the kind to stick with in kindergarten. Boys girls, animals, flowers, marbles, balloons. These are things that come in separate, distinct quantities that are easier to model. Children know how to draw a picture of those things, but they don't know how to draw a picture of pounds, for example. So that would make it much more difficult to solve. As children work with mathematical situations, they're going to gain experience with the syntax of word problems, which is really important, and also some frequent vocabulary that shows up in word problems. These are some of the words that need to become meaningful to your learners. As you work with learners in modeling situations and in strategy shares, it would be wise to connect these words with the actions that children make when they're acting out situations. But I do caution you not to tell children that when they see these words, it automatically means an operation. That was called the keyword approach, and there's some disturbing research on the keyword approach in terms of children choosing wrong operations if the word is listed there. So for example, here's a first grade problem. There were 6 cats in all. 3 were indoors and the rest were outdoors. How many cats were outdoors? Here you see in all. A child who's been taught to believe that in all means you add will get this wrong. Furthermore, in first grade, they will see problems like this, and this is one they're expected to master in first grade. So we really don't want to have to undo a misconception that they developed in kindergarten in order to get them successful with this. So the best thing to do here is to really help them see how these words play out with their actions, rather than coming to some sort of strict rule: when you see this, it means that. So they're going to learn their vocabulary by making connections between that language and their actions. As children gain experience with word problems, it's a good idea to have them try making their own. It also helps you to see what they understand about the syntax of word problems, and it gives children a good chance to attend to that structure consciously think about that structure. In addition to that, some of their word problems are just too cute. This one is from my archives, and I have the parents' permission to show it to you. This little girl's understanding of the syntax of word problems is actually very good, but her understanding of garage sales is a bit limited. As you can see, her literacy skills were fairly well developed for a kindergartner. If you have a child who cannot communicate a word problem in written language, you can always have her dictate the problem. I've indicated on this chart which problem types are designated for kindergarten. The other problem types are optional, although I should say they're not to be emphasized by any means at the expense of the targeted problems for kindergarten, and there's really no obligation to do them. Now, when my daughter was in kindergarten, I tried to make sure that she saw all of these problem types because I wanted her to understand how important it was to constantly think about what was going on in the problem rather than fall in some default mode about what you do with the numbers. When I did give her the other problem types, I tended to give her number sets that were very straightforward for her. She had really good part-whole relations for them. So while with an add to result unknown problem, she might have been working with larger numbers or numbers that were outside of her, really strong part-whole relations. When we would do a change unknown, I would drop the number sets back to something that I knew she really had a good sense of that. So for example, all of these would have been fair game for her because by mid-year she had the 5 can be broken into a 2 and a 3 totally down pat, as well as all the other combinations of 5. Now that's not necessarily true of all your learners though. And so what you can make sure, one child, as a mother, I was able to control that. For whole class, you have to make decisions. But certainly if you have some students who are ready for a challenge and you're looking for ways to differentiate for them, you can drop the number sets back to something that's well within their part-whole relations and then challenge them with some of these other problem types. Problem solving is intrinsic to the nature of mathematics, and it should be present in our work even with very young children. The standards of mathematical practice make this clear, and it's impossible to fully address these standards of mathematical practice without a curriculum that has a fair bit of problem solving. So as we look at these particular standards, consider your current approach to problem solving and whether it addresses them. First, making sense and persevering. If you have to tell the students what to do, then they're not making sense of the problem. So you need to construct situations by which they're acting things out, making sense, and able to even justify why they acted it out the way they did. And they need to have enough complexity that they have to persevere. They have to try to make sense of the problem. And persevere through that process in order to reach success, which can then be validated. They also have to make a lot of decisions. How should I use this tool? How can it represent exactly what's going on in the problem? So how does my actions and these counters, what does it represent going back to the problem? And how do I use these tools effectively to get to a solution? The work that children do in kindergarten problem solving lays a critical foundation for learning to mathematize real-life situations. And this is a lot more difficult than we give it credit for, because it requires that we learn to decontextualize real-life scenarios and attend just to their mathematical relationships. In the next 2 lessons, we explore solution strategies that kindergarten children use to accomplish that difficult goal, and we consider ways to support their early efforts. If you would like to know some more information about the topics in this lesson, check out these references.